Hello YouTubers. Today I'm going to talk to you about some of the most fundamental concepts when it comes to building software, specifically web applications, but you can also take the concepts that I'm going to talk to you about today and these fundamentals into desktop applications development, mobile application developments, or even back-end processing services development. These concepts will help you a lot in the long run when it comes to building projects. It doesn't matter whether your project is little, medium, or bigger size project. It doesn't matter that you're building a distributed system or a monolithic applications. These concepts are very, very important when it comes to building clean and organized and well architected software. And I'm not claiming that this is the only way to build better software, but this method is definitely very, very effective when it comes to architecting your software and building better applications. I'm going to start here with an ASP.NET Core application because I know a lot of people are interested into building their software, or microservices, or even their web applications in this technology, but you can definitely use the same concepts anywhere else. So let me start a new project in here real quick, and I'm going to tell you, why what we're doing is very important. I'm going to call my project here ABC, just because it's just ABC of software. And I'm going to pick up a web application that has a model view controller. Just something specifically, I'm picking this up because it's very similar to the idea of having an MVC project. We're still leveraging that concept, but we're building on top of it. So this is an MVC project. This is a project that has already things broken down into views and models and controllers. And for the longest time, I've heard people talking about how your logic should live somewhere between the models and the controllers. Maybe the models will deal with the external, storage. This is where you get your data, and your controllers is doing the logic to render it and push it out to the views. And that's great, but your code starts to get really, really confusing super fast when you're trying to break out that logic into something else. Let's say this is a web application that has some logic. Let's say I don't want the web interface anymore. I want it to be a mobile application. Where do I look? How do I break that code? It becomes very cumbersome, especially if you're test driving your software. If you're building your software in the sense that you want to verify each and every step of the way, this really doesn't work. So MVC is great, but what's better than MVC is to break down your code into a couple of more categories that will help you break down your code into the real concept of separation of concern. If you're familiar with solid principles, it would actually make a lot of sense. A lot of people would lecture you for hours around, oh, we need to have a separation of concern, but what does that really mean? What does it look like in the real world? This is what I'm going to show you today. I'm going to create a couple of more folders in here. One of them is the brokers, and one of these folders are the services. So what is a broker and what is a service, and how does that play with the controllers, models, and views? When you think about your software, you think about three important things that happen no matter what your software is. There is a category of things when your software is trying to do an external call to other service to get some data or send some data. Right? So let's say your software, for instance, is trying to send an email message, right? Something happens in your system and you're trying to shoot an email message from your system. You need to call an external resource like SendGrid or whatever email server you're trying to use to send that message to the outside world. So there is the external calls that your application makes to do things negotiating with an external service. A database situation comes to mind. Almost a lot of the applications that are out there are using one way or another form of storage, right? So you need something to have the knowledge around communicating with storage, communicating with external resources to save data and retrieve data and delete data and update data, the CRUD operations, right? So that's one category, dealing with external resources, dealing with external things in the outside world, outside of the domain of your project, right? There is something in the middle here, another category, where whatever you're retrieving from the outside world, you will do some logic on it and process it before you spit it back out from the to your views or your UI or whatever you're using. A good example of that would be, let's say you have a database with some students, right? And the database has the student and has their grades in math and geography and whatever, right? The external resource class, which is responsible about communicating with the database, will only give you that data, will give you the student and their grades in every subject. But that middle class, what I call a service, is going to handle the logic of calculating all these grades and returning the total grade of a particular student. The total grade of a particular, calculates the entire grade. So that's some logic that's based on some data that came from the outside world, right? That logic doesn't belong to the class, the broker, that only knows about retrieving data from the database. That logic belongs to another category of classes that we call services that will deal with doing only the business logic in there. And it may or may not call other brokers, it doesn't matter. The business logic itself lives in this category that we call services. So these are brokers and these are services. The rest you already know about. The controllers is your API communication coming from the outside. Your controller should not have business logic in it. That's not very wise. And that's simply because what if you don't need controllers anymore and you need that business logic that you have to plug it in a Xamarin app, a mobile app or a desktop app. Now you're going to try to pluck out all these pieces of code that has logic and extract away all the HTTP response and mapping handling between the incoming calls and the posts and the gets and the... You don't need to do that. All right. This is a lot to deal with, so I want you to take that in and try to think about what I'm trying to tell you here. So you have brokers, you have services, and you have controllers, and you have views, and above all of this you have a model that's shared across all of that, right? What that means is when we're writing our software, if I want to build a broker, something that deals with the outside world, let's call it iStorage broker. When you're building that, it makes it a lot easier for you to abstract away the, let me zoom in, yeah. To abstract away the stuff that deals with external resources. So later on, let's say you're using SQL Server and you decided to use Cosmos DB or use NoSQL of any kind like Mongo, whatever. You don't have to worry about dealing with your business logic to deal with that. Instead, you have a storage broker that knows how to handle that, right? So let's say our interface here, for instance, has a method called, let's say, a list strings. And let's say get all data. I'm going to try to keep this as abstract as possible because this is very, very important stuff when you're building software. So you have a storage broker that knows how to communicate, has the configuration part, that knows how to communicate with the outside world, right? But on the service level, let's create another interface, and let's call that interface iData Processor Service. And what data processor service does, it picks up the data, does some processing on it, and then spits it back out through the controller, right? So I'm gonna implement here, I'm gonna write here another method, and I'm gonna call it, this guy returns a list of strings as well, but these are process strings. And let's say that is process data. So there is one broker that talks to the outside world and gets the data, and there is a service that processes that data, right? And then on the controller level, we can build here a little controller as an API controller with read-write actions. And let's call it data control. Let's call it data controller. It's an empty controller that exposes that data to the outside world, right? Just some random controller that does things, right? Don't worry about the controller at this point. Let's just focus on the brokers and the services, right? So on the service level here, I want to write an implementation for my service. So I'm going to go in here and create a data processor service, which is the implementation of the iData processor service. So I'm just going to go in here and say iData processor service, right? And what this guy does, what the squiggly red line, if you do control period, it will create semi-implementation of the methods required to be implemented for this class to conform with the interface. All right, so I have process data, iData processor service. How do we test drive that? How do we test drive that? Now, this processing data here is something that is internal to your service. This is where your tests need to focus, right? A lot of people like to go to the extreme of saying, hey, I want to test my brokers, I want to test my controllers, I want to test my views. Maybe the views is a good point. If your brokers and controllers are doing what they're supposed to, being a very thin layer that communicates with the outside world, then your test here should also only be integration test, like an end-to-end test, which will cover the brokers and the controllers. But the unit level test, this is where we need to focus on from a service perspective, the services that contain your business logic. This is where unit tests becomes very, very useful to verify the logic of your system. And you don't have to go through multiple scenarios in your integration test. From an integration test perspective, if you're hitting the controller and it's returning a 200 and you're hitting the broker and it's actually communicating with the database, then this happy path is already being covered. You don't have to worry about that part anymore. But the part that you have to worry about is the multiple cases when it comes to the business logic. And I'm going to come down to that. So let's create since we're using dependency injection to test our stuff, and I don't have any tests yet because I don't have any implementation yet, because you're not supposed to write an implementation before you write a test. You need to write the test first and then make that test pass, make that test fail because there's no implementation, then make the test pass by writing an implementation and then refactor your code. So that's the red, green, refactor, red, green, refactor. That's the best way to accumulatively build in software and add in more tests as you go. Before I do that, there's something important here I need to do. And the constructor, because using dependency injection, I'm going to create a private member in here. I'm going to call it iData, what did we call iStorage broker. And that is storage broker right here. So this storage broker here, broker as a term, it's a negotiator, something that talks to the outside world and gets you some data or sends some data for you. So this is my private class member, and I expect, because we're using dependency injection, if you're not familiar with that term, in short terms here, insert description, you're basically controlling all the dependencies that your class need before it runs your logic. And you need to control that through the constructor so you could verify your logic. You can see what your logic is doing by stubbing all the responses that comes in from these dependencies. So in this case here, I'm going to pass the iStorage broker as an input parameter, right? and then I'm going to assign that to my local class member, which is storage broker. So I'm assigning this to this, and using this here is very important. A lot of people use the underscore to define their class members like this. That's not a C# standard way of writing code. Even if it's written across multiple, maybe 1,000 GitHub repo, that doesn't make it the standard. Okay, that's something that was carried over. I like to call it cargo culting from C++. What C# standard really is around is to use this to define your class member. All right, so that's my class member. So this .storage, that means that's my class member right here. Now I have a fully formed, non-implemented class that I can test. Right, I have a method that I'm trying to test that throws a non-implemented exception. I have the constructor, I have dependency injection in place, I have my dependency passed in. Now, let's go build a new project in here. Let's call it XUnit. And let's call it ABC tests. I want you to pay attention to the naming convention here that I'm doing. You know, ABC tests. So it's your project and then your project tests, and then inside these tests I'm going to create here a folder just to honor the exact structure of my existing project, and I'm going to call it services. And inside of this guy here I'm going to name it exactly the same name as my service. So it's going to be data processor service tests, plural, because it's going to have multiple tests in it. Alright, there are 3 libraries when you're writing tests that are very, very important, that'll make your life so much easier, right? There are 3 NuGet packages that you can use that'll make your life so easy when you're test driving your software. The first library that we want to care about is mock. Mock library is basically a library that will help you stub or mock the response on the behavior of the dependency in your class. So I'm going to do MOQ here. Pick up mock, 66.5 million downloads on this library. Can't be wrong. It's a pretty good library and a lot of people are using it. So let me install that first. Let's give it a second there. Alright, it's installed. So mock. It's a very important library. We need it to mock our object. Right? That's the first library. The second library that I really care about is a library called Object Filler from Dynamics. Instead of you going in and trying to say name equal and then coming up with some name and hard code that, that's not best practice. You want to test a behavior instead of testing hard coded values, right? Think about programming as building pipes. You're building pipes to test that any liquid will go through these pipes, right? It could be water, it could be juice, it could be honey, it could be milk, it doesn't matter what it is. So it doesn't make sense when you're trying to test these pipes to specifically identify in your test what kind of data, what kind of flow liquid is going to go through these pipes. If you're building glasses, let's say cups, right? It doesn't make sense that you test your cups against milk or water. You need to test it against a random number of things. Hot things, cold things, warm things. See how your cup is going to hold up against using it for many various different kinds of liquids, right? So you know where the parameter is for your application. So do not test through hard-coded values. Test behaviors by generating random values and passing that in. But generating random values could be a little bit cumbersome. So you need a library called Object Filler to take care of that for you. And I'm going to show you now that Object Filler, what it looks like and what it does. So let's go in here, manage NuGet packages, and just type in Object Filler. Dynamics Object Filler, 65,000 downloads. Not that popular lit, but I'd say that's popular enough for me. It's what I personally use on my day-to-day projects to write better software. So Dynamics, it'll generate things for you. For instance, if you go in here and say new Dynamics dot object filler dot See, it can generate for you things like cities, city names, country name, even IP addresses. It will generate an IP address for you. Random data that is quick to easy. So I'm just gonna go with a name in here just to show you real names, and I get to say get value, right? If I do something like that, and I'm just gonna say assert true here just to halt my test. If I go in here and just do Control RT to start my test, it should hit that point. And I'm going to show you now how it just generates a name for you without you having to think about what you're trying to generate. So if you look at the name here, it says Trissa Horn, right? It generates names for you, you know, without you having to worry about coming up with these things. And it's beautiful when it comes to passing full objects to it, and it will fill in that object for you automatically. Go ahead and explore that. This is off topic. We're talking about the fundamentals of building ASP.NET Core applications. All right, so this is, let me change the file name here as well. Call it Data Processor Service Tests. It matches, so the file name matches the class name. Now, when you're writing a test, break your test into 3 categories. Break your test into 3 categories that you can work with. The setup part of the test, which is the given. The actual running of the test when you run the application. And then the verify part of your test. The part where you need to verify whether your test actually worked, whether your method did what it's expected to do. And I'm going to walk you through that in a second. So in the given part, if you go back to the data processor service, if you look at your data processor service here, the most obvious thing you're going to see is the dependency, iStorage broker. So we need to mock that dependency and mock its behavior in order for us to be able to just test what the data processor service is doing, right? So if I do Control minus in here, it takes me back to the page where I was, and then I'm going to say var data, what's it called? Storage broker mock. Let's stop here for a second. I call it storage broker mock because what I'm going to create, the mock that I'm going to create is not the object itself. It's not the storage broker itself. It's a mock of that storage broker. And then if you do .object, that will be what the storage broker is. The reason why I used var in here instead of the type, because from a best practices perspective, if the right side of your definition, variable definition, is obvious about the type, you don't have to repeat that. That's redundant. So let me show you how that works out. You're gonna go and say new mock. I need to pull in that library, control period. Here's mock. And then you pass in whatever interface you're passing to your service that you're trying to test. So I'm going to say here iStorage broker. Now, I'm pretty sure I typed that wrong. iStorage, like that. Now, it can't find iStorage broker because I didn't reference that project yet, but Visual Studio is so awesome. It'll tell you, hey, you have a project in here that may have a definition for what you're looking for. So I just clicked on that, and there you go. It pulled it in my dependencies. It became a dependency ABC project right here with all its own dependencies, and everything here is good and dandy. So this is my broker, right? I'm still in the area where I'm setting up my my behavior here. So we know that iStorage broker, if you go to the definition part of it, we know that it has a method here that's called get all data, right? So what we want to do, we want to go and say storage broker mock dot setup. So we're setting up our storage broker, and we're passing in here a predicate that says when you are being called with get all data, return a list of strings. Return a list of strings. Now, this is where Dynamics comes in very handy. Dynamics in here will come and say, okay, you need to generate a list of random things. Let me take care of that for you. So instead of generating a list like this, let's go back to Dynamics and say list string returned, or let's say return data, yeah, return data. Right, or you can call it the broker data, you can call it whatever, storage data. Now where does Dynamics come in? I could go and say new Dynamics.object filler, and I could pass to that filler a list of strings like that. And what's going to happen, let me take a new line in here so you can see what's going on, right? This guy here, the right side is obvious. It's going to be a setup, so I don't need that. And let me reference Dynamics as well as a namespace. So let me go here and say Dynamics object filler. So this is my filler right here, filler list of strings. So generate a list of strings. I'm using an alias. Let's use that. All right, here we go. We return data, right? And this guy will generate for me a bunch of data. So let's go here and say list of strings, right? This is my filler. And then we can go and say list data list, or just say return data, returned data. And let's say return data filler dot create. And the beautiful thing about this guy is that it can create a list of things for you, or even multiple of these lists. So actually, instead of saying list of strings, let's just say a string and let it return for us an I enumerable of these values. So I want to create, let's say, 10 items. 10 items in that list, and then say, what does it return? Create an I enumerable. So let's return that as I enumerable, which is also a list, like that. Right? Can I return that in here? You sure? You bet we can. So we can say returned data. Can I say dot to list, just to confirm to that? Yes, you can. Dot to list. We can even do it on that level so it doesn't look weird. We could say here's a list of strings, and then let's go in here and say this, give me this guy dot to list, like that. So this way I could just say return data. So what happened here, if I run my test right now, if I go in here and do Control RT, it'll generate a list of strings that I haven't predefined, and I shouldn't worry about that part. If you look at your return data in here, we'll create 10 items, all have some values in it. Random values, mnemonic, whatever. It doesn't matter, right? It's just a bunch of values, right? Great. So we mocked the behavior of this broker. And because when you're testing your stuff, you test your stuff in an accumulative way, like one feature at a time, one thing at a time. If you put 5, 6 functions, calls, and logic in your service method, and then you try to test it, I assure you, you're going to miss one. But if you accumulatively building your test, it's going to be a lot easier for you to test everything. So that even the test name will change. Just like right now, should call storage broker. That's all we're testing. We're verifying that it called the storage broker. We don't care about anything else, right? So in the when area here, this is when we're actually going to run our application. So I'm going to say var data processor service equal new data processor. So I'm actually creating the actual service in here. Let me pull the dependencies, and then I'm gonna pass in my mock. That's the dependency that I set up, right? So what it needs here is a storage broker mock dot object, because the mock itself is not the object. It's the object that it cares about. So this mock itself is just a mock, but this object is the storage broker that we care about. So now I passed in that dependency, Now what I really care about is to make the call. So I'm just going to go and say data processor service dot process data. I don't care about what it's doing. I just want to verify for starters that my method is making the call to that storage broker. So in the then area here, I'm going to go and say whether your method is returning something or not. You could verify that by simply saying verify that storage broker mock.verify that the broker was called during that test only once, times.once. And you're going to need that a lot because sometimes you want to verify if you have an if statement. Let's say you have an if statement, you have some conditional of any kind, right? You have if do this, else do that. You want to make sure that this if statement was never visited. And the way to verify that is to say, make sure that whatever happens inside that if statement was called 0 times, was called never. And you have that option in here. You could go in here and say times dot never, right? You could even say at least once, at least this number of times. It doesn't matter. You have the options. In here we say once. Actually, once is the default parameter, I think, so that should be fine. Also, so all right, we have all that stuff, all good and dandy. It would be nice from a best practices perspective to leave a message, right? To leave a message in here that says why, if this test failed, why did it fail, right? For instance, if it never was called, you should say something like storage broker should be called at least once for data processing. Whatever message you want to put in there, it's a best practice, you know, to make sure, first of all, don't make sure your lines are not too long. Like if it exceeds 120, like right here I have 87 characters. If your line of code is over 120 characters, it's probably better if you break it down. Naming conventions are very important, but it's also a best practice to leave a message to tell people why your tests have failed, what is it trying to test, and why did it fail. So we have a fully formed basic test in here that says create a dependency and make sure that dependency was called at least once. Now, since our implementation here is not in place, this is a true test-driven ASP.NET Core application. What you want to do is to run your application and make it fail, so it's Control-RT. And then it fails because it says it's not implemented exception. You have not implemented anything in here. So the next thing we want to do is to go green. Now the test has failed. Let's make it green. If you look on the left side in here, you'll see all your tests. This is our test in here. It's not in green, it's not in red, it's waiting for you to fix it. So let's go in here and say this, which is the broker that we called, dot get all data. So this way we're confirming and verifying that we've gotten some data and we did something with it. All right. Now, since this method expects a list of things, we're just going to say return all data, just so we confirm that the return value of the test of the method is a list of strings. All right, we have that in place, all good and dandy. Let's try again and run our tests. So our test here is passing. It's passing because this guy has been called only once, and this guy has been called at all. If we call this guy multiple times, like this dot storage broker dot get all data 2 times, this test will blow up, will fail. I'll say you said it, we expected it to be called only once. It should be only called once. Expect this test to fail, and here's it failing. And the reason why it's failing is because storage broker should be called at least once. Let me go back here. What happened? Test, yeah, at least once. Expected invocation on the mock once, but was 2 times invoked. It was invoked 2 times. So it'll even tell you, you know, that this was invoked, right? So remember that we used in our test here a couple of things. We used a dynamics to create a random list for us, and we used mock to verify that things are mocked. We're going to come back to the third one, the third most important library, very shortly after we do this. So now the next thing we want to do, we want to verify that we have done some logic on the data before that data is done. We have done some form of logic on that data before we return that data on the outside. Let's say the logic that we want to do here is to make sure that everything is in uppercase. Everything is in uppercase. How do we verify that? So we get to go here back to the given area and say list string expected result. So this is what we expect to get back from that method, right? And our expected result is basically the return data dot select. I'm going to turn every item in that data into itself dot to uppercase. So everything in this item, let's say that's what we're returning, to uppercase, and then we want to convert that into a list like that. So now everything should be good and dandy. So this is our logic here. With the data that we get back, we do some business logic in it that we turn everything into uppercase and then we spit that out, which means that in addition to that verify part in here, we could go and say, here is a list of string. This is the actual result. So in every unit test you're building, you have an actual and expected. Let me minimize some of that stuff in here. So the actual result, and the actual result is what the process data comes in handy. Now, here's the problem. If you compare two lists using the native methods in XUnit or MS Test or whatever you're using, it's gonna fail. And I'm gonna give you an example for that right now. Let's say you have a list, this is just an example. Let's say you have a list, let's say this is list A. And this list A has these bunch of elements, B and C. And I'm gonna create a list just like it. I'm gonna call it list B. So I did control D in here, so I repeated the line before. If you go and use assert equal, which is the native method, and assert that A is equivalent to B, like this, watch what happens. Did my test pass? It looks like my test has passed. List A. Oh, maybe because these are very primitive types. Let's create a quick internal class in here. Let's call it student. Let's complicate things a bit. And let's say the name, let's say it has a name. So property, string, and this student has a name, right? So let's say you have a list of students. So I'm going to add in the exact same student in both of class. So a new student, and this guy has a name, and his name is Hassan. And I'm going to do the exact same thing in here. So first of all, the type here will change. That'll be a list of students. There you go, student. Student, there you go, and then let me paste that guy in here. So both lists have the exact same object in them. You have Hassan, student, object, exact same. Now let's verify our theory. If you use assert equal, and then you have list A and list B, and I'm gonna do Control RT, I expect this thing to fail because it's trying to compare, like the comparison that it's running there. It says even these are exactly the same lists, it's still failing, right? So it's not doing the right comparison. What a lot of people do is that they iterate over these lists, and you would be lucky if these lists are ordered and now you have to compare object to object. Instead of doing all that stuff, use this new NuGet package. It's not really new, but it's very, very useful. Let me install this NuGet package, and it's very, very useful here. It's called the Fluent assertions. This is the trifecta of these three libraries. You have Dynamics, you have Mock, and you have the Fluent assertions. And what Fluent assertions is, if I go and say list A should, look, it has a beautiful Fluent API. Let me just pull in the reference here. Should be equivalent to list B, like this, and I go and run Control RT. Now it's going to give me the right stuff. Now it's going to tell me, yep, these two are exactly equivalent to each other. Watch. Pass. This is my test right here, and it passed. Some people may say, well, I don't think it's really doing the right thing. No, I'm going to show you now it's doing the right thing. If I go to one of the names and say this is, for instance, Cody, and I go and do Control RT, it's going to fail because these lists don't have the exact same values, the exact same types. Watch. And fail. Cody is not equivalent to Hassan. So that's the third most important library. Now that we went on a tangent, let's go back to our actual testing here in place. We have created a sample list that we expect to be returned, right? So we've created a list. This is expected result, and this is the actual result, right? So now let's use Fluent assertions to verify that. So let's say, so actual result, you should start with the actual, should be equivalent to expected result, right? And like I said, be nice and leave a message for the people to know why. So here they have a thing called because, beautiful. And this has failed because, now why this should be equivalent to, is because returned lists should be both uppercase. Now, you went over the line here, your code is too long, take a new line. There's nothing wrong with that. Take a new line and say, here's my code. Now it's a lot easier to read. It's all within the same window. Your entire method actually should be within the same window. If it's not, it's only not fitting in here because I am at 210%. But if I go back to 100%, this is my entire method. Something that you can see in one view, right? Don't have methods that are way too long that people don't understand. If you're doing some work in there, just encapsulate it in a method, even if you're going to use it once. Okay, let's go back to 150% and let's try to run our test. Now, our test here should fail. Test should fail because we're expecting uppercase, and what we're actually getting is lowercase. Is that what it is? Let's find out. Did it pass? Boom. It failed. Why did it fail now? If you look at the error here, you will see that it's saying, I expected this uppercase to come back, but it's actually lowercase. Uppercase, lowercase, right? So it's not doing the business logic that we want it to do, right? In which case, we want to go back to our service and say, oh, don't return just all data. Do a little bit of work here. And for every item in that data, put it to uppercase to uppercase to upper, and then that dot to lists. So that should do the business logic part for us. Is that the case? I don't know. Let's go find out. It passed. The test has passed because now the business logic in place, which means it should call the storage broker now, should convert retrieved data to uppercase, or whatever you want to call it. Should process data. Be very explicit. Try to explain to people why you're trying to accomplish here when you're writing your software. All right, let's go back to the architecture. Let's go back to 20,000 feet high. So what we have here, we have the services part and we have the brokers part, right? And all of these should encapsulate the missing. I feel like these are the missing pieces when it comes to your application, right? So the thing that you want to care about when you're building an API, let's go back to the code here. If I'm building a data controller like this, all my data controller should worry about is the instantiation, CTOR, the instantiation of a private member that's called iData processor service, data processor service, and you want to pass that as a dependency injection as well. So it's iData processor service, data processor service, and then that'll be this dot data processor service equal whatever you passed it in here. So let's make that guy smaller a little bit. So now it's exactly the same way. This guy has a dependency injection. It does the thing. Now, some people will tell me, okay, are you going to test the controller? Some people do. Some people don't. I personally don't care because controllers should not have any business logic in them. I think controllers and brokers should be covered with integration tests end to end. So in this case, whatever this controller only care about is to say return this dot service, data service, and then get and then process data. That's all this guy should care about from an implementation perspective. I don't care about testing that. Some people do. It doesn't matter to me. Controllers and brokers are dummy terminals that you can throw away and replace at any time. But that business logic, this is where all the beefy stuff is happening. This is where all the fireworks are happening. So you want to pay attention from a unit test level perspective to that stuff. All right, so this means that we walked through an entire application from brokers to services to controllers, and now you're returning that data, which means that if my broker here has ever had an implementation, let's say call it storage broker. Let's say this storage broker talks to whatever is out there. So let's say it implements iStorage broker. I'm not going to create a database for it. I'm just going to return some hard-coded data just to show you what I'm trying to resemble here. It's returning a string. And let's just add in some names in there. I'm going to say Cody. I'm going to say Robert. I'm going to say Hassan. I'm going to say Kenny. You know, as many names as you got, right? And then, so this is my list. Now, none of that stuff will work unless you tell your startup class how to resolve all these interfaces that you've built, right? So if you want to resolve these interfaces, what you want to go is to say services.add transient translate iStorage broker, storage broker. Translate that into storage broker. So every time it will try to instantiate the data processor, the data processor service, it will see that it needs an iStorage broker, and they'll go and look at the add transient area here and say, oh, resolve that to storage broker. The same thing happens with the controller. The controller has a dependency on the iData processor service. So I'm going to go ahead and say for every iData processor service like this, return data processor service. So now my my startup understands how to resolve these dependencies based on a concrete classes, right? All right, that's great. So I have a data controller, and that's API.data. So if I run my application now I get to test the end-to-end part. Now I get to go and say, is my broker working? Is my controller working? Is everything working as expected? If I go and say /API/data, it should return the list of these people. That is test-driven development. You wrote some tests, you made them fail, then you made them pass, you refactored, you wrote more tests, you made them pass, and now we have the integration test where you're testing things end to end. You know, the same way happens with the views. You could build views on top of these controllers to render that data, and everything here is based on the model. I know this has taken too long. There's a lot more to talk about here when it comes to the little intricacies of breaking your application into brokers, services, models, brokers, controllers, and views. Feel free to drop me a comment in the comment section. This is one of the longest videos I've ever made on my channel, so I apologize for the long video. It's very important. There's a lot that I'm trying to encapsulate here in this one video, so I hope that was useful for you, and feel free to ask any questions or any comments, concerns. Feel free to drop that in the comment section. I will be dropping more videos around best practices from an architecture perspective and from a coding perspective, along with my usual videos of talking about new technologies now that the .NET Core 3.0 is coming out. You know, there's a lot to talk about. There's a lot of technologies that we want to explore together. I ask you, please don't forget to like and subscribe, and I'll see you in another video, and thank you for watching.